half. Alright, we're going to be graphing rational functions today. So what is a rational function? It's a function of the form f of x equals p of x over q of x, where p and q are polynomial functions. So it's a fraction. It's a function made up of a polynomial over a polynomial. Alright, the most basic type of rational function is called a reciprocal function, 1 over x. So if we pick x values of the following, to find our y values, we're going to take the reciprocal. So the reciprocal of -2 is -1/2, -1, -2. The reciprocal of 0 is undefined because 1 over 0. All right, and then we have 2, 1, and 1/2. Because this thing is undefined at x equals 0, that's what makes a vertical asymptote. So x equals 0 is going to be a vertical asymptote. So we're going to graph that. And in this case, our y equals 0 is a horizontal asymptote. So here's our basic pattern. So from 0, 0, we're going to go left 2, down 1/2, left 1, down 1, left 1/2, down 2. So this piece curves and follows the asymptotes out. And then on the other half, we're going to have 1/2 up 2, 1, 1, and 2, 1/2. So here's the other piece of our graph. Rational functions usually have two pieces. Alright, so our domain, so x cannot equal 0, so it's all reals but 0. And our range is y cannot equal 0. So here's some more characteristics about our reciprocal function. So notice that this thing is decreasing on both intervals. So we're decreasing on from -infinity to 0, and then again from 0 to infinity. It's said to be undefined at x equals 0. Now the y-axis is a vertical asymptote, and the x-axis is our horizontal asymptote. This is said to be an odd function, but odd here means that it's symmetric with respect to the origin. So that it has rotational symmetry, 180-degree rotational symmetry. That was called point symmetry in geometry. Alright, vertical asymptote is also known as a non-removable discontinuity. It occurs when the denominator equals 0. That's how we're going to find where our vertical asymptotes are. And the horizontal asymptote is the value that the graph approaches as x increases without bounds. So as x gets bigger and bigger, our y is approaching 0. So that's where that horizontal asymptote is happening. Alright, let's start graphing some of these with transformations. So let's look at this basic one. So the basic form of our rational function here is going to be a over x minus h plus k. This is when we can use that parent graph, that reciprocal of 1 over x. Right? So my vertical asymptote is found at x equals h, and my horizontal at y equals k. Well, in the example of this graph, they're both 0. So we're going to graph our vertical asymptote. You always start by graphing the vertical and horizontal asymptotes. Alright, so I'm going to use my parent graph, but I'm going to make a shortcut here. I'm just going to use the positive half. So I'm going to use these points, and then I'm going to rotate. So take the reciprocal. In this instance, my a is -2. So I'm going to multiply all my y values by -2. So I'm going to get, this should be undefined here. I'm going to get -4, -2, and -1. Alright, so let's go. We're going to go half and down 4 for my first point. Right 1, down 2, and then right 2, down 1. So that's going to be my first piece of my graph. Well, because this thing has rotational symmetry, the second piece of my graph is going to end up over here. Alright, so I'm just going to go the opposite. So instead of going right a half, down 4, I'm going to go left and up 4. Left 1, up 2, and then left 2, up 1. And that's going to give me my second piece of the graph. So I did twice the work with half the points. Alright, remember our domain, all reals but x cannot equal 0, and our range is y, all reals but y can't equal 0, those asymptotes. This graph doesn't touch the x-axis, so there's no vertical x-intercept, and there's also no y-intercept. Alright, look at another example. In this case, we do have an h and a k. Our h is equal to 3, so that's going to make our vertical asymptote x equals 3. And our k is equal to 2, so our horizontal asymptote is y equals 2. So, like always, we graph the asymptotes first. It lets us know where we're going to start counting from. It's like a vertex. HK always gives us where we start counting from. Alright, I'm still in that basic form, so I can use my reciprocals. So I'm going to use, like I said, I'm going to half my work. I always want to put 0 there, it's undefined. This time I don't have, my A is 1, so I can just stay, my Y stay. Alright, I'm going to start counting from the intersection of my horizontal and vertical asymptotes. So go right a half, up 2, right 1, up 1, and right 2, up a half. So here's my first piece. I'm going to rotate 180 degrees and do the opposite. So left a half, down 2, left 1, down 1, left 2, down a half. Alright, so my domain is all reals but 3. My range is all reals but 2. Alright, x-intercept. This one I can read the x-intercept off my graph. So it's at 2, 0. The y-intercept is a fraction. Let's do some math to find that value. So I find the y-intercept when x is equal to 0. So I'm going to plug 0 in for x and solve for y. So I get negative 1/3 plus 2. So if I simplify this fraction, I'm going to get 5/3. So my y-intercept is 0, 5/3. Alright, graph number 4 is a little bit different. Notice we have an x on the top and on the bottom. So this is not, we can't use our parent points here. This is not a reciprocal function. X on the top, on the bottom. But still a rational function. So it still has rotational symmetry. So I still find the vertical asymptote is the 0 of the denominator. That's always true. So that means x equals 1 is my vertical asymptote. So my domain, x cannot equal 1. Alright, my horizontal asymptote, because I have an x on the top and the bottom, I make a ratio of a over c. So a over c, my a is 4, my c is 1. So 4 over 1 reduces to 4. So that's going to give me my horizontal asymptote. So as always, we graph our asymptotes first. So y equals 4. Alright, I can't use my parent points, so I want to do some arithmetic. So let's start off by finding the x-intercept and the y-intercept. The x-intercept is the 0 of the numerator. So make sure you write that down, the 0 of the numerator. So we're going to set 4x minus 2 equal to 0. So if I solve that, I'm going to end up with 2 over 4, which is 1/2. So 1/2, 0 is my x-intercept. Alright, I'm going to graph that from the origin. So 1/2, 0. Now the y-intercept you find when x is equal to 0. So if I substitute 0 in for all the x's and simplify, I'm going to get negative 2 over negative 1, which is positive 2. So 0, 2 is my x-intercept. Well, that's going to be enough to get me my pieces here. So this piece of my graph is going to come in and respect those asymptotes. Hit that a little bit better. And I can still rotate my points, but I'm going to count off of my origin here. I mean off of my HK, not my origin. So to rotate this point, it's left 1 down 2, so I'm going to go right 1 up 2. And this is left a half down 4, so I'm going to go right a half up 4. And so that's going to give me my other piece of my graph. If you would like, you can use Desmos to get more points, or you can plug them into the original function. All right, let's do range to make sure we answered everything. So y cannot equal 4, so all reals but 4. All right, so that's a rational function. So when you have an x on the top, x on the bottom.